Hello and welcome back. So today in this tutorial we'll be looking at another question based on conditional trigonometric identities. So here we're given a condition that sum of three angles A, B and C is equal to pi radian. So we're using this information and we're taking the left hand side of this equation in order to solve for our right hand side, which is 4 cos A dot cos B dot sin C. So here is our given condition. Now what I'm going to do is I'm going to subtract c on both sides of the equation, so this gives a plus b is equal to pi radian minus c. Now I'm going to operate this term, this expression by sine at first and then by cos. So on operating by sine, I have sine a plus b is equal to sine pi radian minus c. We know that sine pi radian minus c is equal to sine c. Similarly, if we operate by cos, then we have cos a plus b is equal to cos pi radian minus c, and cos 180 degree minus c, or cos pi radian minus c is equal to minus of cos c. So I'll use just these two information from our given condition a plus b plus c is equal to pi radian. Now I'm going to take the left hand side of our equation. So here is our left hand side of the equation, which is sine 2a plus sine 2b minus sine 2c. So I'm going to apply the formula here for sine c plus sine d. Let us assume that it is in the form sine c plus sine d. Actually it is. The formula for sine c plus sine d is 2 sine c plus d by 2 dot cos c minus d by 2. So let me apply the same formula here. Sine c plus d by 2 is 2a plus 2b divided by 2 dot cos c minus d is 2a minus 2b, and then divided by 2 minus sine 2c. Now 2a plus 2b divided by 2 is simply, if I take 2 common, then I have a plus b, and similarly I have cos a minus b here, since these two on denominator and numerator get cancelled out, and sine 2c here. Now instead of a plus b, I can write sine c. So 2 sine c dot cos a minus b. Now I'm going to write the formula for sine 2c, which is 2 sine c dot cos c. Now I can take 2 sine c common, and then inside I have cos a minus b and then minus of cos c. So for this minus cos c, what we can write is, we can write positive cos a plus b, cos a minus b, and then plus cos a plus b. Now if we look clearly that these two expression, it is in the form cos c plus cos t, and we can apply the formula for cos c plus cos t, which is 2 cos c plus d by 2 dot cos c minus d by 2. So here I have 2 sine c dot 2 dot, so cos c plus d by 2 is c, plus d is a plus b divided by 2 dot cos c minus d is a minus b, and then minus of a plus b, which is minus a minus b after distributing the negative sign. So we can get rid of positive b and negative b, negative a and positive a. Finally what we have is 2 times 2 is 4, and then we have here sine c, and cos a plus a is 2a. 2a divided by 2 is simply cos a, and cos of minus b is minus 2b. Minus 2b divided by 2, we can cancel this 2, so cos of minus b, we know that cos of minus theta is equal to cos theta. Similarly we can write that, at first I'm going to write it as it is. So here cos of minus b is equal to cos b. So after rearrangement, we have 4 cos a, cos b, and sine c as our right hand side. This is what we have to show. I hope it is clear to you, and thanks for watching.